Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth.
The most distant human-made object in the universe, Voyager 1, has sent what could be its final message back to Earth after nearly half a century of exploring the vast unknown. This last transmission is nothing short of astonishing, leaving scientists and space enthusiasts alike in awe. What secrets lie within this final message? What does it mean for the future of space exploration? And how did a mission launched in the 1970s defy all odds to become one of humanity's greatest achievements? The ambitious beginnings of the Voyager mission. The story of Voyager begins in the 1970s, a time when the outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, were aligned in a rare configuration. This unique arrangement, which occurs only once every 175 years, presented an unprecedented opportunity. A single spacecraft could visit all four planets in sequence, using gravity assists to swing from one to the next. NASA, determined to seize this cosmic opportunity, launched what was initially called the Mariner Jupiter-Saturn 1977 program, later renamed Voyager. The two Voyager craft, both launched in 1977, were built to last 5 years. They are now approaching 50 years of operation and are respectively over 15 and 12 billion miles away. They have left behind the influence of our star and entered interstellar space. These are the only spacecraft that have been there, Cummings marveled. Decades later, the craft and their antiquated computers have each encountered a number of glitches, which have been repeatedly remedied by a clever group of devoted Voyager engineers. The latest hurdle, however, could be serious. NASA reported that engineers were still working to fix a stubborn problem identified in December. They can send messages to Voyager 1, but no science or engineering data is being sent back to Earth. There is an issue with a critical onboard computer, the Flight Data System. The space agency more recently received a memory readout from Voyager 1. At such a great distance, it takes nearly a day for a message from the craft to reach us, which the team is now scrutinizing for hints of a solution. The prolonged issue has space onlookers worried. The plan for Voyager 1 and 2. The plan involved two spacecraft, Voyager 1 and Voyager 2, designed to explore Jupiter and Saturn, with the potential to continue on to Uranus and Neptune if they survived the harsh conditions of space. Both probes were launched in 1977, just weeks apart, Voyager 2 on August 20 and Voyager 1 on September 5. The numbering reflects the order in which they would reach Jupiter, not their launch dates. Each spacecraft was built to last about 4 years, but engineers added extra capabilities that might allow them to survive and travel to the far edge of the solar system or even beyond. Little did they know that this if everything goes well scenario would turn into one of the most extraordinary space missions in history. The technology behind the Voyagers. By modern standards, the Voyager spacecraft might seem primitive, but in the mid-1970s, they were technological marvels. Each craft had a total of 69.63 kilobytes of computer memory, many times smaller than the size of a single smartphone photo today. This limited capacity forced engineers to devise careful strategies for storing, compressing, and transmitting data. The spacecraft relied on 8-track style magnetic tape recorders to store data, ruggedized to survive the extreme radiation and temperature fluctuations of space. Communication with Earth depended on a high-gain parabolic antenna, which had to remain precisely oriented toward our planet. Each Voyager transmitted with a power of about 22 watts, but by the time the signals traveled billions of miles, they were so faint that NASA's Deep Space Network, DSN, had to use massive 70-meter antennas to sift them out from background noise. Powering the Voyagers were 3 radioisotope thermoelectric generators, RTGs, which converted heat from decaying plutonium into electricity. This eliminated the need for solar panels, which would have been impractical beyond Jupiter's orbit. Over time, the plutonium decayed, reducing the power output and forcing NASA to shut down non-essential instruments to conserve energy for critical systems. The Voyager missions changed our view of deep space. The Voyager missions, originally conceived to explore Jupiter and Saturn, have vastly exceeded their original two-planet itinerary. For Cummings and some of his Voyager colleagues, that was always the plan. After all, the craft were nuclear-powered, they wouldn't run out of fuel for decades. The biggest problem was getting it past the launch pad. The physicist recalled a number of failed launches. A lot of us had a goal of getting to interstellar space. Soon after launching, both craft made good time to Jupiter, venturing by the gas giant in 1979. They revealed the planet like never before. Scientists saw Jupiter's roiling atmosphere with vibrant belts of clouds traveling in alternate directions and teeming with giant storms, some bigger than Earth. But the Jovian moons were stars of the show too. Besides the volcano-blanketed Io, the mission captured views of ice-clad Europa, with giant cracks crisscrossing the surface. Intrigued planetary scientists have continued to investigate Europa and now suspect a briny ocean, reaching some 40 to 100 miles, 60 to 150 kilometers, down, sloshes beneath that icy surface. Another NASA probe bound for Europa will soon depart Earth. Saturn, rings, moons, and a fateful decision. After Jupiter, the Voyagers continued deeper into the solar system, reaching Saturn in quick succession, Voyager 1 in 1980 and Voyager 2 in 1981. Saturn's iconic ring system was a major focus, and the spacecraft captured high-resolution images that revealed thousands of narrow ringlets with intricate structures like spokes, braids, and scalloped edges. But the most pivotal moment came when Voyager 1 made a close flyby of Titan, Saturn's largest moon. Titan's thick, opaque atmosphere, rich in nitrogen and methane, fascinated scientists. However, this maneuver altered Voyager 1's trajectory, flinging it out of the plane of the solar system and preventing it from visiting Uranus and Neptune. Mission planners had to choose between sacrificing Voyager 1's chance to explore more planets or gathering critical data on Titan. They chose Titan, a decision that would pay off decades later with the Cassini-Huygens mission. Beyond the planets, into interstellar space. After completing their planetary flybys, the Voyagers embarked on a new mission, exploring the boundary between the Sun's influence and interstellar space. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind gives way to the interstellar medium. 6 years later, in November 2018, Voyager 2 followed suit. The data from these crossings surprised scientists. The temperature in the boundary region was much lower than expected, and the interstellar magnetic field was stronger than predicted. The Voyagers also detected a curious cosmic hum at around 3 kHz, possibly caused by background plasma vibrations in interstellar space. The final message and the future. By the 2020s, the Voyagers were operating far beyond their expected lifespans. In November 2023, Voyager 1 experienced a memory failure, rendering it unable to send coherent data. After months of painstaking efforts, engineers successfully re-uploaded essential code in April 2024, restoring communication. This remarkable fix highlights the ingenuity and dedication of the Voyager team. However, time is running out. The RTGs are steadily losing power, and NASA expects to begin a phased shutdown of major subsystems around 2025. Eventually, the Voyagers will fall silent, but their legacy will endure. The golden records, a message to the stars. One of the most enduring aspects of the Voyager mission is the golden records, 12-inch gold-plated copper discs attached to each spacecraft. These records contain sounds, images, and music from Earth, intended to tell the story of our planet to any extraterrestrial intelligence that might find them. While the likelihood of the records being discovered is minuscule, they stand as a testament to humanity's curiosity and hope. The Voyagers have left the solar system, but their final message reminds us of how far we've come and how much more there is to explore.